So, good day students, and welcome to today's nugget on how the energy contained in biofuels can be used in industrial processes. In the last nugget, I mentioned 3 examples of industrial bulk products that might be produced using modern biofuel technology instead of the most common processes used today. The 3 examples I chose had one thing in common. In all 3 cases was the influence of the fuel analysis and composition not important to the product quality. In the case of aluminium recycling, the product, the aluminium metal, was protected by a slag layer. For the building brick, it is not unusual that one of the raw materials may be ashes. And anyway, the brick are already in the solid state when the baking process starts, so ash components will not diffuse into the brick and change their properties to any extent during the process. For cement are 2 major components, calcium and silica, and these are also major components in many biofuel ashes, so in most cases will they not have a negative impact on the product, unless of course, we are talking some of the most special cement qualities. But there are lots of examples where the product quality will be strongly depending on the composition of the gas atmosphere in the process chamber. So let us have a look at a few of these. Just assume a bakery. The health inspectors will immediately stop your production if you use household waste as the fuel in the ovens, and they can trace heavy metals like cadmium or mercury from batteries, or if they can trace dioxins in the bread. Or think about a whiteware factory. If you run the glazing furnaces firing wood and you try to sell wash basins or bathtubs where the white glazing is dotted with soot, your retailers will most likely select another manufacturer. Or assume you run a crystal glasswork or a window glass manufacturer. If the glass furnaces are fired with wood powder containing too much iron in the ashes, then all your glass will become green. So there are a number of industrial products where the product must be separated and protected from the combustion gases. In these cases, you have 3 major options. The first one is to make the fuel clean enough. This can be achieved if biomass is converted in a process where ash constituents and raw material contaminants are separated from the product fuel. This is mainly the case in biochemical conversion, and biogas as well as bioethanol can both be purified and cleaned. Similarly, may fatty acid methyl esters, FAME, be made pure. With some of the recycled biofuels, such as hydrogenated vegetable oils, HVOs, produced from waste oil from households and restaurants, the cleanness of the product is strongly depending on the input oil and the pre-treatment. Generally, does the cleaning of gasifier product gas require that the gas is first cooled to ambient temperature, so the cleaning process tends also to induce an energy loss. If the fuel cannot be made clean enough, you may use an intermediate heating medium. In that case, you will have to have a heat exchanger in the system. The hot combustion products will then heat up the second medium, and the second medium will be in direct physical contact with the final product. The medium may then be selected not only to avoid a negative impact on the product, but may even be chosen to have a positive impact. Just go back to the case of whiteware glazing. Some colored glazing may require a gas with a special composition, like a slightly reducing atmosphere, to attain the full and rich color you desire of the glazing. Using a heat exchanger, you will have the full freedom to set the gas atmosphere in the process chamber completely independent of the fuel properties. The only limitation will be that the fuel can provide the sufficient temperature. The third main option is to heat up the process chamber walls from the outside and then rely upon radiative heat transfer from the walls to the product. This is the common situation with electrical heating. The heating elements in an electric furnace are usually situated in or just inside the process chamber walls and heat the product only by radiation, just like in a bread toaster. And this can also be achieved using radiative tubes. A radiative tube is a tube inside which the flame and the hot combustion products are contained. The tube then becomes red hot and the tube transfers heat to the product by radiation, just like an electric heating element. In this case are the tubes exposed to very high temperatures and high gas velocities from the inside, and the corrosive resistance of the tube material becomes crucial to the lifetime of the installation. The last options, heating from outside or heating by radiative tubes, also opens up for the use of any specific atmosphere in the process chamber. One example of an intermediate temperature process where a protective atmosphere is used is the bright annealing of steel. The process runs at about 900 degrees C, and the atmosphere is typically a mixture of hydrogen and nitrogen gas. Electrically heated bell furnaces are often used. But the process could also be run using biogas fired in, say, radiative tubes.